Hi there, this is Mr. Sand, and I'm just going to talk to you about finding a tangent line when you've got um, position versus time graphs, or I guess you could do like velocity versus time graphs too if you wanted. This is just finding the tangent line on a graph right here. This is all we're going to practice doing today. The main idea, the main idea is if you think about any point on this graph, I want to try to find a point where if you zoom in close enough on this, let's try to zoom in. I haven't done this yet. Where is zoom? Zoom. Zoom. Oh no. Zoom. That doesn't work either. Shoot. Well, we're not going to zoom. Okay, we're just going to, if you think about how you can get closer and closer and closer to this point right here, and it kind of gets closer and closer, can you draw a line that goes through that point, that captures that particular slope at that particular point? So right here, if I was using all the clues around me where the slope is, if the slope is there, so the slope right here at this point right here, I would say it's something like this. If I was going to draw a straight tangent line, it'd be something like this right there. I'm going to do a lot of examples around here, and hopefully this just kind of gets you thinking about where the tangent line would be. So I'm going to try another one over here. I'm going to circle this one. So this is the point I'm trying to capture. So just imagine, as you get closer and closer and closer, this little window right here, you can see, if you're not looking at anything else, what does that line look like? It looks like a straight line that goes right there. Okay? It's okay that it goes through more than one point, but my main idea, oops, there we go. My main idea is that you're trying to capture this line, the slope of this line, when you get smaller and smaller and smaller. Maybe the best way of doing this, I'm just thinking about this now, maybe the best thing of doing this is drawing an incredibly small circle around this, say this point right here, and say, okay, well, what's the slope at that point? If I'm looking very closely, I can see, okay, it looks like this. I'll just extend this line, I'll extend the line as straight as I can in both directions. And I'm trying to draw a straight line. Now, it's fine that it, like you can see, it kind of overlaps with this brown line underneath it. That's fine. I'm just looking at the slope at that particular point. What is that slope? That's what I care about. And I extend this line out so I can find the slope of this line. Okay? So these are all points right here that I'm talking about. These are points that we'd find from the time. So let's say this is like, I don't know, 8 seconds. This is the instantaneous velocity at 8 seconds. It looks like it's a negative instantaneous velocity. Over here, look straight down. Let's call this, I don't know, 10 seconds over here. And at this point right here, let's say that is, I don't know, 7 seconds. Let's look at some more points over here. At this point, right at that point right there, if you look at really closely inside that little circle, let's see if we can mirror that line inside that circle. Just very small. Now you don't have to be exact here. I just want to get a good, whoops, that should be a straight line so you can see how inexact this is. We're just trying to approximate what the instantaneous velocity is. So at this point right here, you can see that the instantaneous velocity is less at this point right here, at this time point. Let's call this 6 seconds. At 6 seconds, the instantaneous velocity would be less than at the instantaneous velocity at 10 seconds. So we're just trying to compare here to the different kind of instantaneous velocities. Let's look over here at this line, right at this point right here. Okay, let's say that this is 5 seconds. 5 seconds. The instantaneous velocity here looks like it would be, I'm just trying to mirror this line, something like that. Oh, that. Okay. Okay, let's go over here. Let's say that this is, let's go at this point right here where there's a lot of change going on. Let's say this is 4 seconds, and you're going up. Okay, at 4 seconds, just zoom in really close, and then all you do is just draw that line, try to cover that line as best you can. Oh, that's a good line. Okay, we're just approximating here. Now at 2 seconds, Let's do this. Let's go up 2 seconds and see what the instantaneous velocity is at 2 seconds. I'll circle that point right there. And it looks something like this. Something like that. Okay. What about here at 1 second? I circle a line right there. And I say, okay, well at that point, it looks like it's right there. I'm just trying to look at that little, maybe the little window that can help you. Here, let's look at 7.5 seconds over here. I'll look at this. Okay, if you just circle it, you can see it helps you kind of just see that small space in that circle, and you can kind of approximate what that slope is just inside that circle. Don't look anywhere else. Just look at that side of the circle and try to trace that line. That's probably the best way of doing a tangent line, just looking inside that small circle and tracing that line. That way you can see where the slope, look at the slope is changing throughout this graph. The instantaneous velocity is going, and you can look at this right now and say, okay, where is the steepest part of the instantaneous velocity? What second, at what time point is this the steepest? What's the highest or the biggest slope, positive slope in this graph that you found all these instantaneous velocities? Well, you look at some of them, you can easily kind of rule out as not being the highest. So this one's obviously not the steepest. This one's going down, so that's not. This one's going down, so that's not. This one's not going up. So there we go. Now we can compare the slopes. This one looks pretty steep. It is steeper than the second, so we'll cross that one off. So right now our leading candidate is 1 second. We compare it to all the other ones, and I'm looking at these, and I don't see, maybe 10 seconds, it's close, but still it seems like the slope at 1 second is our highest slope. So I'd say from all the points that we have so far, that at 1 second, the instantaneous velocity is the highest. Okay, so this is, again, it's approximate. If you would have said 10 seconds and you would have shown me that you drew the tangent line and you showed that the slope was steeper at 10 seconds, I would accept that. Okay, this is just an approximation of the instantaneous velocity. This isn't going for, we're not going for the exact instantaneous velocity here. This is an approximation. So as long as you get close by doing this technique of drawing a little window in here and seeing if you can trace that small slope inside of that window, then I will give you full credit. Okay? So nothing to worry about. Just do your best. And yeah, hope this helps.